My name is Thomas Seacrist. I'm a research engineer here at the Children's Hospital of Philadelphia. I'm a biomedical engineer by training and have been involved with CChIPS for pretty much the majority of my research career for the past 17 years. Primarily, the first 10 years, I've been focused more in the impact biomechanics space, ATD biofidelity, but for the last 6 or 7 years have shifted more towards the human factors lines of research, primarily in the areas of young drivers and how they're interacting with ADAS technology. So I wanted to take a moment to highlight just a few of the research areas that we're working in and some of the interests that I have, which are really, as I mentioned, teen driver interaction with ADAS technologies and kind of understanding the factors that will influence their efficacy for young drivers. One of the first study I kind of highlighted is was kind of a focus group and national survey. Really, as ADAS was first beginning to emerge, this is kind of early 2017, 2018, identifying barriers to use amongst teen drivers. What are some of the reasons that they might not be able to utilize ADAS technology? And kind of one of the primary reasons was that parents felt that it would impede skill development and thought that they should not learn to drive in vehicles with that technology, which may be contrary to what we believe, since they are at the highest risk of making driver errors and could benefit from their systems. Second project, I want to draw particular attention to because I think it really emphasizes the benefit of being part of a kind of industry university collaborative consortium such as CChIPS. In that kind of the goal of this project was to really work with the vehicle manufacturers to understand how ADAS technology could be optimized for the types of crashes young drivers encountered on the real roads. So we used naturalistic driving data from the SHARP 2 naturalistic driving study and sat together, us at CHOP, bring our human factors, young driver expertise with members of the industry who brought their kind of vehicle dynamics and ADAS technology expertise. And we sat and we vetted in monthly case reviews these crashes and identified, one, what types of errors the teens were making, two, which ADAS technologies we thought could intervene, and three, primarily, how could they be improved to produce better outcomes for young drivers on the road. And I kind of have an example here at the top right of one of the suggestions for optimization that we came up with as part of our collaborative work. More recently, and utilizing the two technologies that Liz just mentioned in her slide, the MEG and the virtual driving assessment, really starting to explore how young drivers are scanning on the roads and how that scanning behavior may differ compared to experienced and older drivers, with the understanding that we need to probably detect distraction differently amongst them because their eye tracking patterns are different, and also augment their scanning through in-vehicle alerts or through driver training. And what are some of the future directions I see us going from here? Again, I think teens are their own cohort, so kind of understanding how their scanning behavior changes and differs with different types of driving conditions, with distraction, whether road type, do they change at all? And maybe that's something we need to understand, detect in vehicle, and intervene with. I'm kind of thinking with your NCAP's goals of detecting cognitive distraction, so using the MEG, identifying eye tracking metrics that can proxy when teens are focused on the driving task and when they may be mind wandering, and utilizing that to detect distraction, cognitive distraction in young drivers. And then specifically, how do ADAS alerts that are in vehicles today influence teen driver scanning behavior? Are there some customization that we need to do to really get them to scan properly, because they may not know what they're supposed to be looking at? So those are the areas I see as future direction.